My dear students, very good morning. In the last 3 classes, we have discussed about different classes of organic compounds. Today, we are going to do different examples which will cover all the different classes of organic compounds. See, the first example which is given here is butane. Butane means it will come under the class of compound alkanes. As already know that alkanes are single bonded compounds and are so called as saturated organic compounds because they contain a single bond between two carbon atoms. The general formula for alkanes is CnH2n plus 2. If you go on substituting the value of n as 1, 2, 3, 4, 5 and so on, you will be getting the corresponding alkanes. Here they have given you, they have taken the example butane. See here, I am going to take down the example butane. This is the IUPAC name. This is the IUPAC name. IUPAC. What do you mean by IUPAC? What is the full form for IUPAC? IUPAC. International Union of Pure and Applied Chemistry. So, the full form for IUPAC or IUPAC is International Union of Pure and Applied Chemistry. According to this, they have given you the nomenclature. They have taken the example butane. See here, buta. But means it will indicate 4 carbon atoms. It indicates 4 carbon atoms. In the first class, I have told you the chain length and the word root. See, if you go to the first video, you will be understanding about the chain length and the word root. For what carbon atoms, what are the prefixes or word root taken. And here N means it is coming under alkanes. It is coming under alkanes. As you already know, the general formula for alkanes is CnH2n plus 2. That means here 4 carbons are there. That means n value, the value of n is 4. If you substitute the value of n is equal to 4, you will be getting the formula. Here I will substitute C4H2 into 4 plus 2. 2 into 4 plus 2. That is nothing but C4. 4 to the 8 plus 2. That is 10. This is nothing but, see, we have got the derivative under alkane. This is the 4th member which is coming under the functional group or class of compound butane. So this is the 4th member. First member will be methane, second member will be ethane, third member will be propane, and the 4th member will be butane. So they have given you the butane, the IUPAC name for the butane. Now we need to write the structure for this butane. See here, C4H10, it is the 4th member. This is the 4th member of alkane. 4th member of alkane. Now the given question was butane. They have given the IUPAC or IUPAC name butane. Now you need to write the structure for this. How to write the structure for butane? See, already we know 4 carbon atoms are there. 4 carbons are there. 1, 2, 3, 4. And you need to take a bond. You need to connect a bond to each carbon atom. Buta means 4 carbon atoms. I am taking in the chain form. to this, we have to satisfy all the carbon atoms. We have to satisfy hydrogens. We have to satisfy the valency for this carbon atom. You all may know that the valency for carbon atom is 4. That means each carbon atom will combine with 4 other different atoms or groups. So now I am satisfying the valency. Now here I am taking hydrogens. I am satisfying the valency of carbon with hydrogens. The valency of hydrogen is 1. The valency of hydrogen is 1, whereas the valency for carbon is 4. That means carbon can combine with 4 other groups or atoms. It can combine with 4 other groups or atoms. Hydrogen, the valency is 1. That means it will combine only with one other. It can combine it can combine with one other atom or group. Next, this is the structure for butane. But means 4 carbon atoms. I have taken 4 carbon atoms. Simple. Ane means alkanes. That means alkanes means single bonded compounds. Alkanes means, what are alkanes? Single bonded compounds. So this bond should be present here. All the bonds should be single bonded. This is structure for butane. This is the structure for butane. In the textbook they have given you butane. You can take n number of examples. As many examples as possible. For example, heptane. I will take heptane. Hep means 7 carbon atoms. Ane means it is coming under alkane. That means alkanes. That means these compounds should have only single bond. I am writing here. You can see the structure here. Hepta means 7 carbons. 1, 2, 3, 4, 5, 6, 7. I am assigning the bonds to carbon atoms. Now satisfy. Now you have to satisfy the valency of carbon atoms with hydrogens. You can take any other group, not only hydrogen, you can take any other group, but this valency should be satisfied. But the valency for each element or the atom should be satisfied. See, this will be the structure for heptane. Okay, and then we go to the next class of compound, that is but1ene. And they have given you the structures also. They have given you the IUPAC names as well as the structures. See here, students, no need to worry. After seeing all this, there is no need to worry. You just go on solving each and every example. You should solve each and every example. After solving all the examples, you will be getting a very good idea. If a new question is given in your paper, if any question is given to you, you'll be able to solve. And please, you should not think that after solving 1 or 2, okay, you can solve. But no, you should solve as many examples as possible. Next we take butadiene. We go to alkenes. Next class of compound is alkenes. Here I am writing alkenes. The next category is alkenes. Alkenes are double bonded compounds. These are double bonded compounds. That means you will have C double bond C. Okay, here I have to take these bonds. Okay, this is the bond. Here I can take hydrogens or any other group. I can take hydrogen or any other group. That means alkenes are nothing but double bonded compounds. These are unsaturated compounds, whereas alkanes are saturated compounds. And these alkanes, see here one term is also there for alkanes, another term. Alkanes are also called as paraffins. Alkanes are also called as paraffins, whereas alkenes are also called as olefins. Olefins. Alkenes are also called as olefins. And these alkenes are unsaturated compounds. These are unsaturated compounds. These are unsaturated compounds. That means they are having double bond. That means they are having double bond between two carbon atoms. Now going to the example, they have given but1. You can take any example. They have given but1. They have taken but1. Here also first you see the parent chain. This is the parent. This will indicate the parent chain. Similarly here also, this one also, the parent chain. Hepta is the parent chain will be 7. As we go above, the parent chain will be 4. Like this, in alkenes, the parent chain will be 4. The number of carbon atoms will be 4. But means 4 carbon atoms. And ene is nothing but double bond. Double bond should be present. Double bond should be present at first position. At first. Now I will take the structure. 4 carbons. 1, 2, 3, 4. And you can number from left side or from right side. You can number it from the left side or from the right side. If you are numbering from here, C1, C2, C3, C4, we have given the numbering here, and we will place the bonds. Here we have taken but. We have taken the parent chain. 4 carbons we have taken. At first carbon, there is a double bond. See, you have taken one here towards the left side. So here I will place double bond. If it is one here, you can place the double bond here. Okay. So 1, 2, 3, 4. Now we have taken the structure. Finally, what is the step? The final step should be the satisfying. We have to satisfy the valence of carbon. Here already there are 2 bonds for this carbon atom. But the valence of carbon is 4. So therefore you take 2 are there here. Remaining 2 should become. 2 should come here. So here I am writing hydrogens. Here for this carbon, how many bonds are there? 1, 2, 3. Here you have to place 1 hydrogen. See here, for this carbon 1, 2, 3, 4. It is satisfied. This carbon 1, 2, 3, 4 satisfied. Like that you have to check for each carbon. For this carbon, how many bonds are there? Either on either side, 2. How many should come? 2 more. Here hydrogen and here 2 hydrogens. For this carbon, only 1 bond is there. That means how many bonds should be present? 3 more bonds. 1, 2, 3. So 3 hydrogens. I have written 3 hydrogens. So this will be the structure for the but1. I will take one more example. In your textbook, they have given you one example. I will take one more example under alkenes. See here. Hex 4-ene. This is one more example. Coming under alkene. Hex, parent chain is hex means 6 carbon atom. At 4th position, we are having double bond. At 4th position, this is the position. Here I will write the structure for this IUPAC name. This is the IUPAC name. Hex means 6 carbons, as we have already know. We already know that hex is 6 carbons. So 1, 2, 3, 4, 5, 6. I'll place the bond here. See, you can number from this side or from this side. In the previous example, I have numbered from here. In this example, I'll just take the numbering from here. 2, 3, 4, 5, 6. See, I have given you the numbering from the right hand side. Okay, and then here this double bond. What is the position of this double bond? 4. 4 is, that means double bond is present at the fourth position, fourth carbon. See, 1, 2, 3, fourth. After 4 carbon, here you can take the double bond. Fourth, after this fourth bond, we are placing a double bond here. Now you satisfy with the hydrogens. See here, how many bonds are there for this carbon? 1. 3 more should be there. So I am writing H3. You can take this as H3. Here 1, 2, 3. 1 hydrogen. 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2 plus 2. 4. For this carbon 2. For this 3. Now we have balanced this structure. Okay, so this is the structural structure for the Hex4E. Next we go to next alkynes. This is alkane. Example under alkane. But1-ine. But1-ine. See, I am taking alkanes. The third class of compound is alkynes. Alkynes. Okay, alkynes. See here, alkanes. What is alkane? This is also unsaturated, and this is triple bonded compounds. These are triple bonded compounds. That means you will be having triple bond between two carbon atoms. That means you will have triple bond between two carbon atoms. And these are also unsaturated. These are also unsaturated organic compounds. Unsaturated compounds. Okay. The formula for alkanes is CnH2n minus 2. CnH2n minus 2. Now under this, what is the example they have taken? But1-ine. They have taken example but1-ine. 1 means you can take from left hand side or right hand side. But 4 carbons, 1, 2, 3, 4. 1-ine, that means if you are taking like this, if you are numbering like this, at C1 there is ine. Ine means triple bond. Ine means triple bond. That means you should place a triple bond here. 1-ine. So 1-ine remaining. Now you have to satisfy the valence of carbons. 3 bonds are there. So 1 hydrogen here. For this carbon, bond will be there. Here bond will be there. So 3 plus 1, 4. This is satisfied. Now for this carbon 2 are there. 2 hydrogens. For this 3 hydrogens should be present. So this is the structure for but1-ine. This is the structure for but1-ine. Similarly, you can take one more example. Prop2-ine. Prop2-ine. Prop means 3 carbon atoms. 1, 2, 3. I am numbering the carbon atoms. Here 2. So here you have to place a triple bond. 1, 2. Here you have to take the triple bond. Second carbon you are going to take the triple bond. Here after second carbon you are taking the triple bond. Here 1 is there. So H3. 3 plus 1, 4. This is satisfied. 3 plus 1 should be there. So I am taking CH. This will be the structure for prop2-ine. Okay. So next example we will go to the next one. That is benzene. Benzene. So in the previous classes, as I have already told you, what are benzenes? Here benzene, nothing but benzenes are nothing but arenes. These are nothing but arenes. Arenes. So these are aromatic compounds. Aromatic compounds. That means aromatic compounds. How can we say compounds are aromatic? There is one rule called as Haeckel's rule. Haeckel's rule. Haeckel's rule. That is 4n plus 2 pi electron rule. 4n plus 2 pi electron rule. See, if the compounds are obeying Haeckel's rule, those compounds may be termed as aromatic. So under aromatic, benzenes are the most important structures. Benzenes. What is the molecular formula? The chemical formula for benzene is C6H6. C6H6 is the chemical formula. What is the structural formula? The structural formula for benzene is, this is the structure of benzene. We are taking bonds here. Okay. Now you see here, if you observe this structure, if you are going to observe this structure here, see, this is the single bond, this is the double bond, this is the double bond, single bond, double, single, double, single. So here alternate single and double bonds are present. This system is called as conjugated system. If there are alternate single double bonds are present, the system will be termed as conjugated system. Okay, and then here how many sigma, how many pi bonds are present in this? If you are asked a question like calculate the sigma and pi bonds, calculate the sigma and pi bonds in benzene, how to solve, how to do? See here, if they are asking you that question, you have to take the structure. You have to take the structure. Here I am going to take the structure again. Here I am taking the bonds. I am writing the bonds here like this. Here I am representing the structure of the bonds. Okay, so here's all single bonds are, all the single bonds are sigma bonds. All the single bonds are sigma bonds. If there are two bonds, one will be pi and one will be sigma. One will be pi and one will be sigma. So here sigma, here one more pi, here one more pi, here sigma, here sigma. Okay, so here in this, not only sigma bonds are present here, these are also the bonds which I have extended, the bonds which I have expanded, these are also sigma bonds. These bonds are also sigma bonds. See, this bond and this one, these are also sigma. So totally if you are going to count the sigma bonds, how many sigma bonds will be there? 6 plus 6. Sigma bonds will be 12 sigma bonds. And then how many pi bonds? 3. Already I have mentioned here 3 pi bonds. And how many sigma bonds are there? 12. Pi bonds are 3. And one more important thing, students, you must remember the important thing. Sigma bond, these bonds are the strong. These bonds are strong bonds. These bonds are strong bonds. Whereas pi bonds are weak bonds. These are weak bonds. These are weak bonds. Because this is strong and this is weak. Because maximum overlapping will be there in the sigma bond formation. Maximum overlapping. Here you can note down this point. In sigma bond there will be maximum overlapping. There will be maximum overlapping. In one class I will draw the structure showing you the overlapping concept. Okay, there you will be understanding why sigma bonds are strong and why pi bonds are weak. With example you can furthermore you can understand further easily. And here this is weak because there is minimum overlapping. There is minimum overlapping. Benzenes are nothing but arenes. These are aromatic compounds. aromatic compounds are nothing but these compounds will follow Huckel's rule. So the compounds which follow Huckel's rule is aromatic, will come under aromatic. Okay, the Huckel's rule is nothing but 4n plus 2 pi electron rule. I'll explain you this in one class. And then if you go to the structure here, if you go to the structure, I have explained you. I have taken the chemical formula. C6H6 is the chemical formula for, or the molecular formula for benzene. The structure is like this. If you expand the bonds, you will be getting like this. In this, how many pi bonds? 3 pi bonds are there, and totally 12 sigma bonds will be present. Totally 12 sigma bonds. Sigma bonds are strong, whereas pi bonds are weak. This strong, the reason for this is there will be a maximum overlapping, and in pi bond there will be a minimum. There will be a minimum overlapping. Okay. The next example, we go to the next example, that is 1-bromobutane halides. So this is halides. We will take the next class of compound, halides. See here, halides, as all of you know, halides, the symbol for representation for halides is X minus. Halides is nothing but X minus, whereas just halogens are simply represented with the symbol X. If there is a negative charge on X, that is halogen, X is halogen. If there is a minus charge, that is negative charge, it will be termed as halide. Here X you can take as fluorine, chlorine, bromine, iodine, and so you are having further. X is nothing but halogens. So these are the halogens. These halogens are present in the 17th. These halogens are present in the 17th group of the periodic table. So these halogens are represented with the symbol X. These halogens are nothing but these are present in the 17th group of periodic table. These are present in the 17th group of the periodic table. So those elements are nothing but, what are those halogens? Fluorine, chlorine, bromine, and iodine, and so on. The remaining are also there. See here, if we are going to take these halogens in the form of X minus, we will get F minus, Cl minus, Br minus, I minus. So what is the name for this? It is already present here, halides. That means this is fluorine. So we should name this as fluoride. Fluoride ions. These are ions. Chloride ion. Bromide ion. And the last one is iodide ion. Okay, so these are the terms given for halides: fluoride, chloride, bromide ion, fluoride ion, bromide ion, and iodide ion. See here, for the IUPAC, so in order to name the IUPAC nomenclature, in the halides they have given you only prefix, they didn't give you the suffix. They have mentioned the halo as the prefix. So this should be present in the prefix form. They have taken 1-bromobutane. Now I am going to take the example here. I am going to take the example here. 1-bromobutane. See here, 1 means the position of carbon atom, bromo means Br, butane means C, okay, ane. So in the ending, here you have got single bond. The bond should be ane means it is coming under alkane, so single bond should be present. So I am taking the chain here 1, 2, 3, 4. Here at 1, so here you should have Br. You can take on either side, below or towards the left side or at the top, and placing the bonds. Okay, so 1 bromobutane. See here at the first carbon atom I have taken the bromine and bromine butane. So buta I have taken the chain as 4 carbons. Now you satisfy with hydrogens. You have to satisfy the valency of carbon. 2 bonds are there, so H2. Remaining 2 are hydrogens. 1, 2, 3, 4. Here also CH2. Here CS3. So this is the example under halides. Okay. See here they have taken the prefix, as already we discussed. Prefix was haloalkane. Prefix used was, what was the prefix they have mentioned? Haloalkane. Haloalkane. See here. This is the halo. This is the alkane. So what is the halo here? Here. What is the halo? They have taken bromo. Bromo is the halo. What is the alkane here? They have taken, here you can see, butane. Butane. Okay. So halo is bromo. Butane is the alkane is the butane. So we are naming this as bromobutane. See here, bromobutane. So this I'll stop here, and in the next class we will discuss the different examples which are coming under the remaining classes of compounds. Thank you, my dear students.